9.2 lesson is over arithmetic sequences and partial sums. So your objective of this lesson is to find an arithmetic sequence and to model some real-life problems. An arithmetic sequence is a sequence whose terms have a common difference. So from one term to the next, it's the same amount. They're either adding or they're subtracting in arithmetic. So on example 1, these are just some examples. There's no work here. But if you wanted to know if something was arithmetic, you would take the second term minus the first term. So 11 minus 7 is 4. 15 minus 11 is 4. 19 minus 15 is 4. So you would say yes, D equals 4. Okay, on this one, they're going -3 minus 2 is -5. -8 minus -3 is -5. So each time they're going down by 5. So your common difference would be -5. Same thing on example C. You would take the second term, take away the first term, and if you keep doing that and you keep getting the same number, then that's your common difference. All right, the nth term of a sequence, in order to write a formula to find the next number, this is your formula you're going to use. AN equals A1 plus N minus 1 times D. Okay, A1 is always the first term. N is the term you're looking for, and D is the difference. So on example 2, it says find a formula for the nth term of the arithmetic sequence whose difference is 3, first term is 2. So once you write down your formula, then you're just going to plug everybody in. I put 2 where A1 was and 3 where D was. On this step, all I did was distribute my 3. And then to my final answer, I simplified and I put 2 and -3 together to make -1. Okay. On example 3, it tells you that the fourth term is 20. So A4 is 20. The 13th term is 65, so A13 is 65. And then I want you to write the first 11 terms. So in order to do that, you have to know what is your common difference. What are they adding or subtracting to get to the next term? So I'm going to use this formula that we just did, except I don't know what A1 is. But we're going to put A13, because that's the ending term that I have, equals A4. And the difference between 13 and 4 is 9 spots. So I'm going to write 9D. Okay, once I replace A13 and A4 with what they actually are from the problem, 65 and 20, I have one unknown. So I can subtract 20 and get 45. Divide by 9, so my D is 5. So when I come over here to write my first 11 terms, all I know is that A4 is 5. I'm sorry, A4 is 20. But I know that my difference is 5. So I add 5 each time till I get to the 11th term. To go backwards, I have to subtract 5 to get to the terms before A4. Okay, example 4, using a recursion formula. It's kind of the same thing. Find the 9th term. The sequence begins with 2 and 9. So if I start with 2 and then I go to 9, the difference has to be 7. So using the formula from the very beginning, I want to find the 9th term. So where N is, we're going to put 9. 2 is my first term. Again, N is 9. 7 was my difference. Okay, 9 minus 1 is 8. 8 times 7 is 56, plus 2 makes 58. Okay, the next few problems are summing arithmetic sequences. So this is your formula. S stands for sum. So you'll take however many terms you have, divide by 2. A1's the first term, AN is the last term. So on example 5, I have my formula. They want you to sum this. Now, I know it's very easy to just type all that in, and that's fine. But if you count, there are 10 terms, so I put 10 over 2. The first term is 1. The last term is 19. So if you put the first term, last term, 10 divided by 2, put that together, that makes a 100. Okay, example 7 and 8 are exactly alike. They want you to find a certain partial sum. So they want the 150th partial sum, which means after I get 150 numbers written down, what do they all add up to be? So I wrote down that A1 is 5. My difference is 11 because from each term to the next, they're adding 11. So when I come here, I'm going to put 5 where A1 is, and I'm going to put 11 where D is. Okay, I distribute in this step, and I combine like terms to get my formula. Once I have my formula, then I need to find the last term, because in order to find the sum, I have to know how many terms I have, first term and last term. Okay, so if A1 is 5, I can now put 150 right here, and when I put 150 right here, I get 1644. So to use the sum formula, 150 over 2, first term is 5, second or last term is 1644. And when you add all that up, this is the number you get. Okay, example 8 is the same thing, except this time your difference is -5 because they're subtracting 5. So make sure when you plug in where D is, you put -5. Okay, last one, example 9, talks about a business that sells $10,000 worth of skincare during its first year. So that means A1 is 10,000. The owner has a goal of increasing sales by 7,500 each year. So D is 7,500. Assume that this goal is met. Find the total sales during the first 10 years. So I'm going to write my formula down. AN, how much did I start with? 10,000 plus N minus 1, and my difference is 7,500. I distribute to get this step, combine like terms in this step. So in order to sum, I have to know the last year's dollar amount. So I'm going to put 10 into this formula, and this is the answer that I get. So over here where it says sum, I'm summing 10 years worth of money. I started with 10,000, and this is my number after 10 years. So when you add all that up, you get that your sum is $437,500.